Alrighty, thank you everyone for joining this session where I share my experience on working with Dockers in a very basic ways. And yeah, afterwards, if you want to work more using Dockers, I would encourage you to do so. There's a lot of resources online, especially on their own websites and also YouTube videos. And I'm sure that you can find almost everything that you needed to figure out how Docker works and basically utilize it into your development tech stack. All right, let's start. Hang on. Yep. All right. So first things first, what is Docker? So to understand this, we might need to go back to how a machine works. So as you can see right here, normally a machine, a personal computer, for example, a laptop, it's the same thing. They always have three layers. First layer is the hardware, which is your motherboard, your RAM, your hard drives, etc. And then the OS kernel goes on top of that hardware, which communicates directly to the hardware using binary codes, which pretty much none of us will understand. And then the application going on top of the OS kernel. So pretty much everything you see, like the UI interface, all the softwares that you are using, they're all applications, right? And it's very rarely that you need to interact directly with the OS kernel. And right now, I think normally if we want to do that kind of thing, then we need to go down into a lower level programming languages like C and C++, even assembly in some instances, but most of the time you probably don't really need to know. So yeah, that's how the machine are structured in terms of layers. So let's talk about virtual machine, because I think most people are familiar with virtual machines over Docker. They have been there for, I don't know how many years, like 20 plus years. And you might be familiar with things like VirtualBox, virtual machine. Yeah, but like Oracle VirtualBox, probably the most popular one because it's free. And back in the day, that was like the only viable way for students to, play around with networks and all sorts of stuff without actually owning multiple computers. So for virtual machine, they contains two layers of the three layers that we already talked about, which is the OS kernel and the application. Basically, what virtual machine is it package the OS kernel and application into one image, and basically that image will talk directly to the hardware itself. So that's how they build the virtual machine, which is why the virtual machine file or image, it tends to be very heavy. It's probably about 700 megabytes, as far as I remember, for Windows XP image, if I'm not wrong, and then up until like 2 terabytes or something for Windows 10. Depends on what application they put on top of the OS kernel. So what Docker does differently is that it utilizes the same OS kernel as a host machine. But what that means is that, for example, if you're using a Windows machine, right, they will use the Windows kernel and put the application on top of it inside the Docker containers. If you are using a Mac or a Linux, they does the same thing. Well, luckily, the Mac and Linux actually shares some similarity in terms of kernels. So it's pretty much just Windows are different, and which is why we have certain limitation when it comes to Windows if we want to use Docker. So for example, I think Windows 10 Family Edition, they can't run Docker, but you need to purchase like a Windows 10 Professional Edition, which supports Docker in terms of functionalities. So the benefits of using the OS kernel of the host machine is that the image is going to be a lot smaller. because there's no OS kernel packed inside the container. So the image is going to be heaps smaller. I think it's only about like 50 megabytes in some instances, and some other instances it's only like 10 or even less. And also because it's so light and there's no requirement of booting up the OS kernels, the startup speed it's just so fast. Back in the day when you want to turn on the virtual machine, it probably takes you, I don't know, like 30 seconds to 1 minute to be able to boot it up into a usable state. From there until it fully loaded, it's probably take another 2 to 3 minutes. But for Docker, you pretty much just boot it up, and then within seconds, it's ready. All right, so those are the two benefits that Docker offers over virtual machines. And we will go into more details on how it works in the later slides. So for the next slides, I want to show you the components of Docker. So we have 4 main components here. Of course, there are others, but like a lot smaller. So if you want to dive deep into that, there are videos and training materials out there. So there are 4 main components. First one is images. Second is containers. Third one is networks, and fourth is volumes. And I will explain each of that in this slide. So I took some time, like just drawing up a very rough image of how they interact. So basically, the image will contains the pre-built application without any data, without any user data, and this image is basically the one that you download from the public repository or private repository, which they already prepackaged the application without any user configuration or data. All right, the containers are pretty much image plus file system plus any environment configuration you have. And the reason why that is structured that way is because the file system and the environmental config can be built, and it doesn't have to be related to the image, because you can define your own file system, and then you can define your own environmental config, and the container is pretty much customized to your needs. So the third one is networks. So basically, when you boot up a Docker environment, you can also specify a separate network independent with the host networks. For example, so that Docker containers of the same network can talk to each other. This is very useful when you need to mimic a large amount of machines. You want to talk to each other privately. You don't want you don't want application from other networks to be able to intercept the traffic. And most of the time, the most popular sort of case that I see is that one container is the database, the second container is some sort of a server, and you don't want the database to be able to talk to the outside world. So you put it into the same put these two into the same network, and pretty much, they can only talk to each other. They can't even go out. And the fourth one is volumes. Volumes is what contains data. So I mentioned before that container contains the image, file system, and environmental config. You can actually put this file system into a volume if you want, and that depends on your needs. The only downside of not having a volume is that once the container is destroyed, you lose all your data. But if you link the file system with a volume, if the container is destroyed, the volume will stay there. So the data will be kept there, so it doesn't get lost. And if later on you want to restart a container or rebuild the container, then you have the volume already mounted into the file system as per Docker's syntaxes. Yeah, so that's just how they structure a Docker image and containers. And image and containers are often mistaken, or not mistaken, but like they often mix the concept between the two. All you have to remember is that container is more like in your machine, and the image is just like what you want to download from the public repository for now. Later on, you will be able to learn how to create your own image. And basically, the container contains the image plus something else. All right. Cool. Any questions so far? The white line is pretty much the Docker environment, and you can have multiple Docker environment inside the host operating system. Yeah. Cool. Let's do the next one. All right, so just going through some basic command. We'll have a demo at the end of this presentation. So this one is just being here so that you guys can refer to that one later on if you have any issues. So first one is the Docker pull. Docker pull, the only thing is like pull the image to the local machine. So it's equivalent to things like git clone, pretty much. Docker images just display a list of downloaded images. So basically, if you pull multiple images and you want to see what you have downloaded, then you can use this command. Docker run -d mean detach mode, because like if you run Docker run with the image ID, you will go into their own environment, and it just keep the container running on that terminal. So unless you do a detach mode, it will just stay there and then keep the container running. Docker ps -a. If you use Linux and Mac a lot, you would be familiar with the ps, which is the process command. So it's kind of very natural when you look at this command. Pretty much just lists out all the running containers. And -a means -all. Sometimes, if you only use Docker ps, then it will show all the running containers. But if you use Docker ps -a, it will show all the running and the stopped containers, which is very useful when a container just stopped without any message, and you want to know why. But the only way that you can refer to that containers is via their IDs, and they are not listed if you just use Docker ps. You have to use Docker ps -a to be able to see that stopped container. So we'll go into that in the demo later on. All right, and Docker stop and Docker start, pretty straightforward there. I don't think I need to go deep into that one. All right, next one, just continue on the basic commands. So you can use this command to basically run it under an exposed port on the host. So for example, if you want to run a Node.js server instances on port 3000 on the host, but the default port of the Node.js one is probably like 4000 or something, then you can just say Docker run -p and then this 3000 is 4000. So always remember it's the host first and then the container after, and then the image. So it will boot up that container, map the container port into the host port, and then serve it to you. Right? And Docker logs is very useful to debug the log. Like I said before, if a container exit with no message, you might want to look at the log. But because you don't know the container ID until you do the PSO, until you do the Docker ps -a, you will need to get the ID from this command and then put that command into this command right here. The --follow is actually optional. So if you do a Docker logs container ID, they will show the last, I think, 20 lines, 20, 15 lines of the logs. If you do a follow, it will stay there in the terminal, so that if there was any subsequent logs in the future, they will just show up for you. It's very useful when you do error trackings on the servers and all that sort of stuff. You'll probably be familiar if you are using, say, things like Laravel, and then you want to look at the Laravel at the PHP logs, error logs, whatever, and you do some sort of like similar commands to be able to to keep following the logs as it goes. This Docker exec minus IT here, basically the IT means interactive terminal. And what the whole command does is that it will open a terminal to the container. So for example, if you build a MySQL container, then you will be able to go into that container and execute MySQL commands or MySQL queries, whatever. All right. And then this one, it just lists all available networks. And I think this should be enough for you to play around with Dockers very basically. We will go through. We'll briefly go through the Docker compose command or structure of the configuration file, and I will show you the actual projects that we have that we are currently utilizing in the development environment. All right, let's go to the demo, which is probably more interesting than this one. So let me just pulling up some stuff here. All right, so to do the demo, I will show you where you can find the Docker repositories. So you can go to Docker Hub, which is the repository for all images that they have. So for example, in here, I'm searching for MySQL containers, and it is recommended to use the official image rather than over any other kind of images, because like it comes from the actual owner of the technology themselves. So it's obviously it's a little bit more trustworthy and reliable. So let's say that you want to pull a MySQL image, and down here you can see a lot of different tags. You can also see the list of tags here. And what tags does is that it defines different version of MySQL that you can pull. And I think this thing is you can even pull, you know, Docker like 5.5. Sorry, MySQL version 5.5, which is pretty old, like a few years old already. This is a very good way to deal with old technologies. So for example, if I needed to build an environment for CodeIgniter 1, for example, then obviously I can't use PHP 7. I have to use something like PHP 4 or 5, which is only is it also available here as well. I don't think you can easily compile PHP 4 or 5 nowadays. Not that easy. I think I tried before on one of my clients' project. So you can pull like a 5.6 over here, and as you can see, it's like 6 years old already, which is very useful when we need to deal with legacy projects. And even older, but it might not be on this trusted official image. It might be in like some other guys' images that they are generous enough to put up some images for us to deal with these legacy stuff. So let's say, for example, I'm just trying to reuse the MySQL because it's a small image enough for us to do the demo. So in here, you can obviously see the command in here. So all you have to do is just pull this one. I might have to go and see the list of images that I pull. So as you can see, I pulled the MySQL 8.0 here already, which is a good thing. And I think 8.0 is actually not the latest one. So we have 8.0.26. So what I'm going to do is that I will pull this one at latest. So if you just want the latest, the most bleeding edge version, then you can just do a Docker pull of the latest stuff. So right now I say no matching. That's fine. What we can do is that we can pull this exact version out instead. Where's my text? So if the latest say this, that probably means that we already have the latest version, but I'm just trying to do something else just to be sure. Oops, no space. That's fine. So I think we already have the latest one. Let's try an older version than 5.7. If it's not, then I might have been using a wrong syntaxes. Yeah, I think I might have my wrong syntax. So what you can resolve is that docker pull older version. And have a look. It's not that one. Like could be Dr. Image Pool. I could be wrong. Let's try that one. Nope. That's fine then. Let's try something else instead. If I do MariaDB, which I don't have on my local just yet. So let's see if I pull this one into my local, see if it works, and it does. I'll try to go back and see why didn't this one works before. I suspect that because I already have this one there, but it doesn't explain the different version there. But that's okay. We'll come back to that later. So I will wait for this to finish, and then it will be useful for us to notice what are these, and I will explain this in the subsequent commands. Let's try to find a different version so that we can use. Yep, 5.5 looks good. Let's wait for a bit. My machine sometimes it's like, not my machine, but my network. Sometimes slow. Alrighty, and now I will pull the same MariaDB, but in different version. So there are a few things here. As you can see, we have less stuff here being downloaded. Sometimes it's because there so what are these hashes is basically different applications or other images that being pulled by MariaDB image. So one image can contain multiple images, and each of these are pretty much different images. The reason why they split it into these many images is for reusability. So if we use a different version of MariaDB, for example, maybe 3 of these actually already downloaded, so they don't have to re-download it again. And therefore, they only download the updated version of of the application of that certain application of MariaDB to be downloaded. So now, once we downloaded both of the version, we can have a look at that. So we can see the MariaDB at latest here, and then the MariaDB at 5.5. So we all know that the latest, I think I showed you before, the latest one is like 10 point something, right? 10.6. and we also have the 5.5. So we can. So I will show you now that we can actually run both in the same machine. This might be more relatable if you are working with different database version. So if a MySQL version 5 database, you might need to fix quite a bit of things to make it work in version 8, which means that if you are only trying to investigate the projects, for example, you might not want to change a lot of stuff. You just want to build it so it can be run for investigation, which is how the different version comes into effect. And also, if you need to develop multiple projects onto using multiple tech stacks, then this is a great way to handle that. Because before, I remember back in the day, if I needed to work on one project using PHP 5 and the other project using PHP 7, I need to have both versions installed on the same computer, and basically switch between the version to be able to support both, which is a lot more work. And then there's like tons of commands that you have to run to make it smoothly transfer and all that sort of stuff. All right, let's go into Docker run. So what I'll do is that I will do a Docker run, and I will run this MariaDB at latest. And and it says that you need to specify this, which is the user environmental configuration that I mentioned before, which is this one. So most containers will need some sort of configuration to be passed on. And so for this one, I will just do it quickly. This one, you can define it using -e, which defines the environmental and then environmental variables, and then you have to do the same thing for each of these, just for that one. And then boom, it works. So all these logs are being outputted to let us know what is going on. So like the last line here, say that this version of MariaDB has been online on port 3306. And because I didn't use the detach mode, so it will just stay there. And basically, if I do anything that affects this container, it will be logged here. So just to show you if it's already there, please ignore these two. I forgot to close it down, but that's fine. You can see that this one is up, the MariaDB, and it's exposed on the port 3306. And you would have a question why this one is also in 3306, because normally one process can only listen to only one port, and you can't have two processes listen to the same port. I will explain it to you later. But right now, it is up normally here, right here. All right, so now let me do the same thing with the second MariaDB image. So if I do that, Docker run, and I will do the detach mode now, MariaDB at 5.5.6. And obviously there will be that one right there. So it doesn't match. What we need to do is that we need to specify the platform. And this is normally what happens when you try to build an older version of pretty much all the programming languages out there, which means that you need to specify this kind of platform right here. And that's kind of normal because like we are using, like for me, I'm using sort of the newest OS, and we need to specify the platform so that what's the word? The image knows how to compile Docker knows how to compile the image into the containers. All right, so that's one that's done. We can have a look now. I don't know why. So actually, no, -a. Yeah. So as you can see here, this is a very good example of how to look at these exited containers. So right here we see two of them that has been booted up, but pretty much exit because it couldn't keep running, and we couldn't see it in here if you don't use -a. All right. Now I need to figure out why this doesn't work. Right. So container ID right here. What I'll do is .logs that. And that is why that doesn't work, right? So what I need to do is to go back here and add that stuff in. All right, but let's see what else. Yep, so now if I do PS only, now you can see 2 version is up and running. All right. So this is a demonstration of the proof that you can actually run 2 different versions of the same technology on the same machine at the same time, which is really, really convenient. And all you can do, everything you can do from the command line. You can also do that from a Docker dashboard. So Docker actually spent a lot of time building us a very nice dashboard that you can use. I myself don't use it a lot. But if you find it easier for you, feel free to have a look through. I prefer using command line over your interface, but that's just personal preferences. All right, so now you can see like all the images, all the containers, and pretty much the one that's with the green one is the running one. It's running, and a bunch of exited. Okay, so what's next? All right, so I'll quickly touch base onto this kind of start and stop containers. I will try to stop this one, which is very simply Docker stop. And you can see that it's gone, and you can access it through this. So you can see that it's it exited 6 seconds ago, which is this one that I stopped manually. And later on, if I want to restart that one, I just need to copy the container ID to a Docker start, and it's back on. And so very easy to use, and these don't consume a lot of RAMs, in my opinion. But if it does, and you can run multiple instances at once, then you can just switch it off one at a time until your machine can take it and sort of continue with your development. Cool. Now, so I will go on to the network part. So what you see in here, the port here, is actually the internal port of the container. So right now, from this one is a Mac, we can't really connect into this container whatsoever because it's not exposed to the outside world. All right. So what we need to do is that we need to bind this port into a host port. All right. And a host port is we can just determine the host port ourselves. That there is no restriction on that one. You only need to make sure that the host port doesn't is not already used. So things like port 3306 if you have MySQL running on the host, or let's say you just randomly run a port 3000, but you forgot that the running Node.js instance is already on port 3000. So obviously in that case that doesn't work. So what we're going to do is that we're going to expose these two into two different ports. All right. So I will expose. What I need to do is that because once you boot up these containers, then you can't really change it anymore. So what I need to do is I need to stop these two. Stop that. I need to stop these two containers and pretty much rebuild them so that we can use the thing. I'll just quickly go up to that platforms. Now, what I need to do is that I will remember this root password here because like I want to be able to access that in the future. Okay. All right, and then I will need to do sp and obviously the host port first. So what I'm going to do is that I'll put port 4567, for example, and then 3306. The 3306 one binds to this one, and the 4567 is pretty much binds to the host. All right, so I'll run that. Do the same thing with the latest. But I do 14568, right? And I believe that there are a few different environments over here. So I'm going to just delete these things and then see what errors comes up. There's none, which is weird, but let me have a look. Yeah, I expect that. That gives us the message that the latest one exited. So we do the same thing with the logs, just trying to see what went wrong. So they need the root password right here. C root password, root password 2. Oh, sorry. Root password 2, start kicking it up. I'll load it down. All right, checking. So you can see the latest one and the 5.5. And now it has 4568 linking to 306 and 4567 linking to 306. This indicates that the 401 basically means localhost. Right? There is no special about that IP address. So you can link this, you can, when you see this one, it pretty much means either localhost equivalent to 127.0.0.1, localhost, that kind of stuff. And this is the same thing. This is the hexadecimal of the same IP. The second here is pretty much the I can't remember. I think it's the IPv6 version of the whole thing. But right now you only need to know that this port is mapped to this port and this port is mapped to this port. All right, so let's try if we can communicate to them. So I'm going to use data grip. You can use other things, even the MySQL command line as well. I just don't have MySQL on my host machine. So I'm going to use this thing here, which is the database connector, basically. And what I'm going to do is that I will create a new data source. So demo version 5. I'll put MariaDB here. Host is localhost. The port here will be the port that we specified. So for the version 5, I'm going to use 4567. The user is root, and the password is password. Okay, now test connection. It succeeded. And what we can do is that we can just apply and create this connection right here. We'll do the same with the v10. The MariaDB. We'll do the demo v10. All right. The port is going to be 4568. And user is root, and the password is password 2. let's test the connection perfectly. And you can see the version right here too. So that it's two different versions that you can use. So now we can connect to both of these servers at the same time using different ports. And this is not even the network part that I mentioned before. I will not run a network one. I'll show you how the network looks like, but that's about it. So this one is basically port binding so that you can use it on the host machine as much as you want. So some people use this one to map that into a different port so that their processes, let's say, for example, they run a Node.js server, development server on the host machine instead of inside a Docker container. Then they can use localhost at this port to be able to connect to the database. For example, if you want to connect to like Redis or other services, then you do the same thing. Alrighty, I already showed you the Docker logs a bit earlier than I expected, but that's a good thing because we can see like the real cases. Now I'll show you how to get into this container and run certain commands. So I think you remember doing that with the docker exec -it, like I said before, interactive terminal, the Docker container. Bash is basically the what's the word? The shell that we are using. You can use things like this one should work too, but I normally use Bash. All right. And right now you can see that the name has been changed, which means we're already inside the container. We can have a look at that one. We can see the Docker environment file here, and then pretty much you can run any sort of commands inside these containers. However, the image are pretty much very packed. They only contains the absolute necessary for a MariaDB application to run, and they contains nothing else. So for example, you wouldn't see Vim here. So let's say if we find one, the command not found because it's not necessary to run this terminal, to run this application. So they just strip out that command or that application altogether. So there are very restrictive things on what you can do here, but you can also run things like MySQL. All right, and you put the password in, maybe password 2. Yeah, and now you are inside the MariaDB terminal. So what you can do is you can do like create database, for example. SDB. Should I do just that one, just for simple instances? And now if you will go back to that, just do a quick refresh, and not sure if we can show the thing here. If we can't, then I might need to show you from another time. But anyway, let's say I say use. Create tables. Actually, wait, let's not do into that right now. All you need to know is that we can actually execute commands inside an MariaDB or any kind of containers using the Docker exec. All right, and you treat it as a separate server basically. If this is like a normal SSH server, for example, you do like SSH root at something, but this one you just use a different command that goes into the same shell, and then you can do whatever you want with that shell. Okay. Now, what I want to do is that I want to quickly show you the. Do I have Webstorm open? Yes, I want to quickly show you the Docker Compose here. Yep, so simple one first. So the Docker Compose is a utility command that goes with Docker, the whole Docker application. And what it does is that it allows us to create a configuration file containing multiple configuration for different Docker containers, so that you just need to run one command and you can boot up as many containers as you wanted to. So in here, we only have one service or one container to be built. You can have more than that. You can have like 2, 3 of these. That's fine with different things. What else I want to say? And the format of this one is YAML, YML. And basically, it's just a wordplay on XML. Basically, XML, you can have like these kind of tags, right? So things like root and the root, and then you can do, and you can do things like, you know, version 3.1 here, that kind of thing. So this is an XML format, which can be translated into YML. And this is just a wordplay because, you know, Y, X and Y, right? So XML and YML. Later on, we might have ZML. You never know. But basically, they use this format. You can even use XML if you like, but this one seems a lot more cleaner. Alrighty, so for this one, right? I needed to put the platform in, similar to the platform on the command line that you see, the environment, which is the -e -e option, the ports one, which is the -p. So all these like these kind of command can be translated into the configuration file, and then because it's in the configuration file, so you can actually let other people review it. You can save it onto GitHub and basically version control it instead of having it onto the command line like this. It's very easy to be lost in the process of, you know, just over time, it's just gone. All right. And you can specify the networks here. As I touched before, we only have one container here, so the network doesn't really make sense. But if you have multiple, then the networks start making more sense. And this is the volumes, right? So what I do here is that I map this one on the host, and this one's on inside the container. So a trick here is that every time you see this kind of column here, then the one on the left is the host, and the one on the right is inside the container. Same syntax here. This one's on the host, and this one's inside the container. So I just map this into that, so that any change happen here will be reflected here. And you can see all the data right here. Of course, it's in binary, so you can't even read them. But the good thing is that it's ready here outside the container for you. So even if I wanted to delete this service, the data is still here. So you don't lose the data whatsoever. All right, so that's network and volumes for you. Now I want to find the one that, if I have here, I may not, but if I don't, no, actually, I can, yeah, this one. So this one here have two containers. One is the Laravel app, and the second one is the database. And you will see this one quite frequently because the database will always be a separate containers. And if you want to have a server, actual like build server with like Apaches and Laravel PHP, then that's another container. I don't even have Apache server installed in my host machine. So everything I do is through this containers right here. And you can see that the network is defined here, the app network, and then that's the same network, so that they can talk to each other, which you can see. I don't have the example, but that's fine then. What else I want to say? Yes, if this one, say this one is not app network, but app network 1, these two will not talk to each other. They can't recognize each other at all. All right, so that's that means two container has to have the same network name and being defined right down here to be able to talk to each other. And we also have the volumes mapping right here too, which is good. All right. So what does this do like the build one? Because we didn't touch on any build stuff there. So Docker comes with a different configuration which specify the steps to build a certain container. All right. So if you don't want to just get stuff from the default image that you're pulling from the Docker Hub, you can actually build your own image. All right. So this is a whole step to build my own image, because obviously the PHP 7.3 Apache doesn't contain any of these like extra libraries that I need to install to be able to make Laravel works. That's why I need to build my own image. So what I did is that the PHP 7.3 Apache is actually a Debian-based image, which means that it's like a Linux kernel, Debian Linux kernel. They put 7.3 and Apache onto that image, and then they pack it and then send it off, right? But we need more packages. So that's why we pull this one. We actually want to install these kind of thing. We run some sort of configuration here, but we did all this so that we can come to the final image that is usable for us for development. And pretty much for production even, you can use this. You can use sort of the same structure, but maybe different, because you don't want to, let's say, for example, you don't want to install development in Composer. So most likely you're going to be install only production or dependencies of the Composer and then skip all the dev dependencies. Same here as well. So there will be a different configuration for the production build over development build. This, what you see here, is the development build. Yeah, that's about it. Okay, you guys have any question? All on mute. So I guess moving forward, I'm expecting every project to have at least one of these files, so that other developers, say for example, in the middle of the development, then we added one more developer in, and this is the fastest way to actually get them into the state of development the quickest, because they don't need to spend time on figuring out what kind of installation they need to do, or like what else do they need to do to be able to boot up the app, right? So yeah, it's just a lot simpler this way, and also we know exactly what we need to do. Like, let's say for example, we need to deploy onto a VPS, right? And if we don't know, if we don't deploy it as an image, as a Docker image, at least we know what we need to install based on this Docker file, which is the instruction to build the image locally. So if you need to build it on the VPS and then you don't use Docker, you can actually follow these kind of steps and basically boot it up the server easily. Yeah, so that helps in a lot of ways, and it simplifies the deployment step quite a bit. I think in the future session, I'll touch on to Kubernetes and how to deploy a Docker image onto an AWS EC2 instance, so that we can utilize that in the future. Alrighty, that's about it for this session. Is there anyone has any question?
It's good thing.
Yeah, Gerardo, you were saying something?
I think it's good. Okay.
Okay.
I think we need to deploy to VPS using Docker.
Yeah, it will be better if we do that. I haven't written down steps for that one yet, so I'll do that in next week or so that like even the Passpoint project, we can even use Docker to deploy that.
Yes.
Yeah. Cool. Sure. All right. Thanks everyone for joining. I hope that helps you guys on to have a basic understanding on how it works and utilize that in your future projects. Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank
See ya.
you.